Oh, what's up, people? It's 11:11. Make a wish. Okay. Say Thursday. Yeah, today's Thursday. Still on vacation. Pretty terrible vacation, if I'm gonna be honest with you. Other than spending a little bit of time with my mom, that was nice, and she cut my hair, which was really awesome. She did a great job. My mom has always cut my hair. I got my hair cut by like a hairdresser or whatever, or like an actual barber, a few times, and they did good like once or twice, and then like the other 2 times, I probably went somewhere like cheap, like Fantastic Sam's or some shit, but they did a bad job. And there's really nothing worse than being on fire, but almost as bad as being on fire is getting a bad haircut. So you don't want to get a bad haircut, and my mom made sure I got a good haircut. But yeah, the vacation, not so great because my back is totally fucked right now, and I don't know what I'm gonna do. Cause yeah, it's not very good. Anyway, I hope y'all are doing better than I'm doing. But let's jump in and pick up where we left off yesterday. Yesterday we finished reviewing all of the game class attributes to determine whether they were shared, meaning that they need server-side locks to nullify any race condition, and then we began the implementation of said locks, and we had just started that, and that was line 318 in client. So you can see right there, that's where we stopped. So we're just going to pick up there. We're going to separate this, keep the text stuff on the right side and the actual code on the yeah, text stuff on the right side, actual code on the left side. So always get rid of those little notes after the fact, and we'll put just a continued implementation of, or we can just say began, because we began but we really didn't make any progress. Like whatever, maybe we did a little bit. Continued, yeah, we brainstormed, so that's still work, right? Go to client. There we go. Okay, so let's double click this to make it a little bigger. Check our extensions to see if we need to restart any of them, and we okay, so let's go back to get rid of that. Alright, so now we put our little pseudocode here, or brainstorm for pseudocode, and we put if adder name is in locked dict, a dict we need to create which has adder name string as key, associated lock as val, then acquire lock prior to this line's execution. Okay. Yeah, because not every single well, if they all are, but I know round end winner sound bool isn't. So yeah, I don't think we're not gonna create any more attributes. Like that's I say that I'm pretty sure we're not going to create any more attributes. So like we could make a specific set of logic. We can use a specific logic check here instead of some like general thing that would adapt to any changes we might make to this list of attributes. Since we're probably not going to make any more attributes, we can just literally make like a very specific rule that's based off of this list of attributes. So okay, wait a second. We might need the, well, no, not that. We don't need that because that's for the timestamp. Okay, so right here. But isn't the wouldn't we need the lock before this line? Because if they're considered the same object, and I want to say like I want to say they are considered the same object. Um, Meaning the if it's a property at the class level but is created using the um, property decorator such that we, it looks like this right here. Well, not yeah, like this. So you have your initializer, and then at the same indentation level you have a what looks like a method, a class method, but you use the property decorator, and it's now a class property. And you can't actually oh, I forgot to do this. I forgot to I didn't do this right. It's supposed to be at x.setter, right? Excuse me. Yeah, at x setter. That's the format. I forgot to do that. Did that skew our test results? I don't think it did. Let's just check though. So we're gonna control F5 to run this. So we got CLS has Y, because that's Y up here. CLS has X, and it does because it's a property created at the class level. And then we have CLS has underscore X, and it doesn't because you get the false right here, and that's because it's defined at the inside of the initializer at the instance level. Then we have C having X, and it does because it's shared between the class and the instance. And then you have C having Y, and it does because class attributes are also instance attributes. So my question here then is, whenever we create a property, a class, I guess you would call it, would you call it a class property? I guess you would call it a class property. Let's see. I'll copy this code. We're gonna say the above code is the property X considered a class property, an instance property, etc. Or and also if we access this property simultaneously on two threads, one thread accessing it via the class CLS, the class object, and the other thread accessing via the instance object, is that considered a race condition? Alright, property X is considered an instance property. Okay, this is because it is defined using an instance variable self underscore X within the init method of the class. Each instance of CLS has its own underscore X value. No, it doesn't. It's not true. Well, I'm sorry. Yeah, no. Okay, that is true. Scratch that. I'm an idiot. Um, so when you access or modify X via an instance, you're working with that instance's specific value. Okay. Regarding your second question, he didn't really completely answer that question. Regarding your second question about accessing the property simultaneously from two threads, if one thread is accessing the property X via an instance of CLS, and the other thread is accessing it via a different instance, no, not a different. If both threads are accessing the same instance, both using C.X, then you could run to a race condition. Okay, but to manage UTVs, such as locks, ensure that one thread can access modify the property. Okay, he didn't understand what I said though. But if I access it via the class object CLS dot X and then through C.X, is that the same property object? I'm talking about the actual at property object. You access the property X via the class object and then through the instance here, you're dealing with the same property definition, but they're accessed in different contexts. Class versus instance access. Accessing via called a property X as a class level attribute. Since X is defined as a property with at property, this access would result in an error. Further, will not be able to find the property directly on the class since it is not a class level attribute. Well, that's just not true, isn't it? Because we just checked that. CLS has adder X. And yeah, it definitely finds it. So that's not entirely true, is it? Okay, I gotta use the restroom. I'll be back. Okay. Yeah, when you gotta go, you gotta go, you know? You gotta go, so. Alright, forgot to set my timer too. I'll set it for like 45. But actually, I'll just say that was my break. So we'll just go, whatever, just set it for an hour. Okay, so I was disagreeing with ChatGPT here. ChatGPT was trying to tell me that when you access via the class object, it says if you let me make sure it pasted in the code correctly. Yeah, so it did, but it's saying that it would throw an error if I try to access class.cls.x because x is not defined as a class property. Add class method or use add property with a class variable. Yeah, that's not true though. That's not true because we did add property def x and then we checked if CLS has the adder x and it does. So that's not true. I'm not gonna argue with ChatGPT, but what I really wanted to know was the property object itself is defined at the class level, but it is bound to instances when accessed. So while the underlying property object X is the same, accessing it via the class doesn't directly work because it needs an instance context to operate. Oh, ChatGPT kind of failed me there, I'm not gonna lie. This was not a very good answer, I don't think. If one thread is accessing the property via an instance CLS, then another thread is accessing it. Yeah, ChatGPT just kind of failed me there. So okay, here's what I need to know. Because my concern is that I'm accessing the same object, and if cls.x is the same object as c.x, then if it's accessing that same property in a race condition fashion, then we need to put a lock on it. So how do or rather what code would I use to determine if one class property object is the same object as an instance property object? Like I could use probably same class property object is instance property object. Oh, so is. Okay, so to determine if a class property object and an instance property object are the same object, you can use the is operator in Python. See, I don't use is. I've really never used is, honestly. This checks if both references point to the same object in memory. Okay. Code access to the property descriptor. So we have class property equals my class X. Let's look from the top actually. So we have my class underscore X class level internal attribute. Then we have add property def X. Okay. Return self underscore X, X setter, self val, self underscore X equals val. Okay. Now we have class property equals my class X. Okay. And then we have instance property equals an instance of my class dot X. Okay. We have instance equals my class property object equals my class to the actual property object. You need to access the descriptor directly. Yeah, because I'm not so much worried, like, I'm just worried about when we access the property. Like, is it accessing the same thing? Because that's really all that matters. So class property object equals my class underscore underscore dict dunder dict at X. So the dunder dict returns a, isn't that like all the attributes in the form of a dictionary with the attribute name in the format of a string and then the attribute value as the value? Then we have instance property object, which is instance dunder class, and then dunder dict. Getting the property descriptor from the instances class. Okay. Class, let's see. And that's what I want to do. I wanted to compare the actual object, the actual property object. So we have accessing property. This code accesses the property descriptor directly from the class's dict. This allows us to compare the actual property object rather than its value. Okay. The is operator checks if class property object and instance property object refer to the same property object. The class property assignment in this example, my class X, would raise an attribute error since you cannot access properties directly from the class unless it's a class property, which X is not. The demonstration is focused on comparing the object, the property object, so we directly access the descriptors from dict. The class property assignment in this example would my class X would raise an attribute error. That's not true. That's simply not true. Oh, no. It is true. It's true. Okay, it is true. No. Okay, I was confused. All right, so ChatGPT is right, guys. ChatGPT is right. So it's an important distinction here that I was failing to make is if we use the has adder on X here for my class, if we say has adder my class X, which is what we did here, it works, right? Right there. It returns true. Because it has the property object itself. Okay? Like it has X in its list of attributes. And I'm guessing has adder. Okay, so I gotta figure out a few things. Alright. Underscore dict. What does that do? I just need to know what that does because I should know. And then class, and I'm pretty sure this is basically just a way to access like I think class accesses the parent class, the not the parent class, the associated the instances associated class object, right? I think, and then accesses parent object, and then we have the, we're gonna say returns dict of all adders. And then what was the third thing? Oh yeah, what does has adder do? What do it do under the hood? what does it do under the hood? Like, what does it do in the back, under the hook? The hook, the hood, same difference, right? So what does it do under the hood? And like, it just checks. It would probably run dict. Like, that's probably what it does. It probably grabs the dunder dict. And I know that sounds silly, chew my nose in the gutter, but that's what it's called. It's a dunder method. So moving on. So that's what we need to know. So what we're gonna do first, so I can fully understand this, is ChatGPT was right. So if we say print CLS, all right, x.x. Now, interruption, but it didn't throw an attribute error. Okay, no, so ChatGPT was wrong, if I understand it right, because this is printing out a property object. Am I right here? I think I am. I didn't realize I didn't have my my stream started. I mean, I didn't have it broadcast on my YouTube, my Facebook. So yeah, it looks like ChatGPT was maybe wrong here, because in our test, when we print CLSX, it doesn't. Let's just say CLSX, just to check in a different way, we'll say CLS.x, and then print CLSX. Okay, so it does the same thing. It doesn't throw an error. It said that it would. It said that it would throw. This is like an older version of. Sure. Yeah, it says my class X would raise an attribute error since you cannot access properties directly from the class unless it is a class property, which X is not. But actually, since we have this exactly the same, it actually does work. So I'm just gonna note that. But when I run this code, it doesn't throw an attribute error. It returns a property object. My mistake for the confusion. When you access my class X, actually returns the property object itself without raising an error. The attribute error would occur only if you tried to access the property directly on the instance without using an instance method. Here's a refined version of the explanation in code, ensuring clarity on the comparison between the class level property object and the instance level property object. Okay, so I had to correct chippity jippity. So we have class property object equals my class X, and then instance my class instance property object equals instance underscore class dot X. This is also the property object, and then check if they're the same object. Are same. Okay, retrieve the property directly. Property object defined on the class. And then we have instance property object instance dunder class X. Use the same property object from the instances class. Line our same class property object is instance property. The output will be true. So it's saying they are the same. Thank you, ChatGPT, for your help. Okay. So let's run that test. Let's see if we do. So let's print c dot underscore underscore class underscore underscore dot X is cls dot X. So let's look at that last one, and it says true. Okay, so yeah, we're getting there. So doesn't this mean that if we accessed cls.x on thread 1 and c.x on thread 2, and since both of those access the same property object, doesn't that mean we would have a race condition issue? Accessing CLS X in one thread and CX in another thread does not inherently create a race condition because the property accessor itself is not directly modifying shared state, because the property accessor itself is hello?
Yes, hello, Miss Chelsea.
No, this is her husband. This is Joshua.
Hey, Mr. Joshua, this is Mr. Brown. I was looking at Dojo because I was checking a message. I'm Principal Independence, and I was checking something to post, and I seen a message that Miss Chelsea sent to me on here. I usually never check Dojo for messages because they usually email or call out. But I was trying to see what is going on with your daughter, and I guess she's saying another student in the classroom.
Here, let me give you her number so you can call her. It's
Okay.
it's 985
Yes.
956 8439.
Okay. Thank you so much. I'm gonna call her right now.
All right. All right. Bye bye. Uh-oh, something's up with one of my kids in school. Somebody's probably some bullying shit or something. We've had issues in the past with this. Sure that number's right. Number 60. Yeah, that was right. Okay. Anyway, back to this. So we have CLS X in one thread, CX in another thread. Because the property accessor itself is not directly modifying shared state. It's break this down further. Understanding the access. When you access CLSX, you get the same property object, the descriptor, that is used by all instances. I don't really like this song. I don't want it. Yeah, so it says when you access CLSX, CLSX, you get the same property object, the descriptor, that is used by all instances. Accessing CX will also invoke the property method defined on the instance, which uses self_x. Okay. Each instance of my class has its own _x attribute. Therefore, even though both threads are accessing the same property object, they are working with different instance attributes when accessing CX. If one thread reads CX and another thread modifies, then you can encounter a race condition. Both threads are operating on the same instance. If CLS is accessing one thread, CX in another, as long as C is a different instance, both threads are accessing the same instance. Does not modify state. Accessing the property through class CLX does not modify state. Yeah, well, I really wanted to know. Okay, so even if they both access the property object, the descriptor, that doesn't mean, like, that doesn't mean that property object is subject to a race condition. The descriptor itself. Correct. The property object descriptor itself is not subject to a race condition. The property descriptor created by the app property decorator is a class level object. It manages access to the instance variable but doesn't contain any state itself. Okay. Accessing the property descriptor does not modify any instance data. It merely provides a way to get or set instance data through defined methods. Okay. I'm just like, honestly, I feel like I disagree with this. I feel like maybe I'm wrong, but if this were a class level attribute, if this was a class property, which is also an instance property using the property decorator, and we had a class internal attribute, let's say _x, and the property decorator created the class/instance property x, okay? And then if we accessed C, an instance of CLS is x, at the same time that we modified CLS's x, it would access the same property descriptor. So maybe it's saying that that's just a way, like the road to access the state of, because my concern would be that let's say CLS starts to modify X on one thread through that property descriptor first, like a microsecond before the .x. In that case, was the and let's just say that the operation is a little bit faster in accessing versus modification. Now, that would mean the c.x data access would be achieved first before CLSX could actually finish running through the setter. But yeah, actually, I don't think I'm right here, because property, if we're accessing the descriptor, if we're accessing the property object, we're accessing the property object, and the property object has the setter and the getter. So is that right? Let me understand this correctly. Because if they're both accessing the setter, then that would be an issue. But if they were both accessing the setter, then the instance would be creating a new attribute. It wouldn't be setting the value for the class attribute object. So that actually couldn't be a concern. And then as far as simultaneous access is fine, because there is no modification involved, so there's no change of state, right? Yeah. The conflict for a race condition lies in the fact that one state is in the process of modification, while the other thread is in a state of accessing, so that or that it's also in a state of modification. So we actually wouldn't have this issue here. True. I'm pretty sure. Yeah, we're safe. So concerning let's see, the property descriptor is the same object. Yeah, I think I understand this now. Descriptor access. Accessing the property's descriptor itself is safe and does not lead to a race condition because it does not alter the state of the object. Right, accessing. Okay. Instance variable access. Race conditions occur when multiple threads interact with the mutable instance variables that only mutable? Well, no, it still would be... It still could be a race condition, though, even if it's not mutable, because of the fact that... Well, maybe not. Let me think about this for a second. So if something is immutable, if it's an immutable object, like an integer, But if it had like if it was a calculated property and we went to access it without a lock on another thread while the other thread is in the process of modifying, is setting it and isn't done yet, even if that object is mutable, it would still be at risk. Okay, so I have a few questions. Oh, so we'll say mutable versus immutable race condition. Just because object is immutable doesn't mean not at risk of race condition, correct? Because setter could take time while access is immediate, causing bad access would need lock to let setter finish. And then we have the other one, which is the descriptor object has setter getter. Does that object have the setter getter method? I need to understand that just a little bit better. Alright, so now we can access. First we'll ask, does the descriptor object have setter getter? Does the descriptor object have the setter getter methods? Yes, the property descriptor object in Python encapsulates the getter and setter methods defined for that property. When you define a property using the app_property decorator, Python creates a property descriptor object that includes a getter method. The method decorated with property serves as the getter. This method is called when you access the property. The method decorated with add_property serves as the getter. This method is called when you access the property. Setter method. The method decorated with app_property name setter serves as the setter. This method is called when you assign a value to the property. Okay, so yeah, simultaneous access isn't a race condition, which is what it was saying, and that is true. So that's the thing here, is I was understanding the @property decorator as encompassing like a object that included the getter and the setter. But actually it just creates the getter. The @property, like that object is just really the getter. And then the setter is a completely different thing. But don't they have to refer to the same property? I really didn't want to take a whole class on this, you know. I really didn't want to do this. But I feel like if I don't understand something, I have to understand it before I can really move on, you know what I mean? In Python encapsulates the getter and setter methods. Encapsulates the getter and setter methods defined for that property. So it really just looks up a namespace which is static, so there is no race condition there. Even if we were to look up the property object, even if there was an encapsulating property object and then it had the getter and the setter methods within it, even if we access that thing at the same time, there's not a modification going on there. So like that wouldn't constitute a race condition. But if we were accessing the setter, and we were in the middle of the setter, and then we access the getter without the setter finishing first, that would be bad. We want to make sure that that finishes first, right? Okay. Method decorated with property setter. This method is called when you assign a value to the property. Got you. Property value, getter method return, self value. Got you. Setter method. Getter. Okay, so let's look at this. Descriptor equals my class underscore dict at value. Okay. Check if the descriptor has getter and setter methods. Getter equals descriptor dot fget. Okay, so this is checking to see if this is an attribute or a property. If it has a getter and a setter, then it's a property. Create an instance of my class. Instance of my class uses getter instance. Print getter instance. So we're gonna see if the instance my class, and then we have the getter, which is the descriptor dot fget. Okay. Okay, I see. Yeah, I got you. So this gets the, this is the running the getter for that property value. And then we create an instance, and then we use the getter, which gets the same thing. It runs the getter method on value, but it does it in the context of the instance, which would return 0. And then we say setter, which gets the, calls the setter method on the descriptor value, okay, which runs this setter here, okay, and then that's the same thing as this is val right here. 10 is val. Got it. And then we print the getter instance again to run the getter, to call the getter, and then it outputs 10. Okay, yeah, see, ChatGPT is a good teacher. That was good. Okay, I understand now. I understand. I see. I get it. So there really isn't any like it is, we do at a certain level when we access the instance object, property object, versus the class property object. If we access them through the namespace of the class and the namespace of the instance at the same time, we are accessing the same descriptor. But that doesn't intrinsically imply any sort of race condition, because there is no modification going on at the same time. There is no modification, and the actual attribute itself, which would be underscore x, being accessed through a getter at the same time as someone modifying it using the setter, that if they were accessed at the same exact moment would be considered a race condition. So I'm trying to think of a way to actually classify what I'm trying to describe here. Such that when the, and I know this is kind of like splitting hairs, but it's, I want to understand this on a deeper level. So we have, like, is this considered a race condition? If the setter starts but isn't finished, and the getter starts actually after but finishes first, resulting in a bad data return. I don't think that's technically considered a race condition. That's more so considered a it's more so considered just an order of operations issue. It's not actually a race condition. A race condition is when you're accessing two attributes or modifying an attribute at the exact same time as you're at the time of retrieval, or double modification. So I don't think this is technically considered a race condition. So I'm going to ask that next. So we got rid of this one. I pretty much understand that, mostly. I think 99% understand that. Then we have mutable versus immutable race condition. But first I'm going to ask, is it considered a race condition if I have a property X which has a setter getter, and I on thread 1 access c dot underscore x at the same time thread 2 is running the c setter through c dot x equals 1. Yeah, and on thread 1 access c dot underscore x at the same time thread 2 is running the c setter through cx equals 1, and has not yet finished its assignment process yet, resulting in thread 1 finishing access before thread 2 modifies c dot underscore x through the setter, even though thread 2 started its setter process first. That's what I really... Yes, that scenario could indeed lead to a race condition. Thread 1 accessing cx. Thread 1 accesses the instance variable cx while thread 2 is in the process of running the setter cx1. There's a potential for inconsistency. Thread 2 running the setter. Thread 2 starts the setter, which may involve some operations like modifying underscore x. If thread 1 reads x before thread 2 has finished executing the setter, thread 1 may get a stale or inconsistent value. So this is a race condition. Concurrent access. Both threads are accessing the same shared resource cx, which can lead to unpredictable behavior. If thread 1 finishes reading the value before thread 2 has completed the modification, it could lead to scenarios where thread 1 reads the old value or a partially modified value. If the setter has side effects or is performing multiple operations that aren't atomic, e.g. if you have logic before or after the assignment that should only be run once the new value is set, this can further complicate the situation. Okay, so that is considered a race condition. To prevent this kind of race condition, you can use synchronization techniques such as threading locks to ensure only one thread has access. Yeah, so it is race condition. Okay, cool. Got that one out of the way. Now, has adder. What does has adder do under the hood? What does has adder do under the hood? Okay, so has adder function in Python is used to check if an object has a specified attribute. Here's how it works under the hood. Has adder takes in object, and then the name is the object you want to check. Name is a string representing the name of the attribute. We have attribute lookup. When you call has adder, Python performs an attribute lookup on the specified object. It checks if the attribute exists in the object's dict, which contains the instance's attributes, or if it exists in it checks if the attribute exists in the object's dunder dict, which contains the instance's attributes, or if it exists in the class or its parent classes. So if that attribute exists in the parent class or whatever, which would mean it would still be inherited, so it exists at the instance level. Right, so has adder invokes dunder dict. Gotcha. Using get adder, internally has adder actually calls get adder. So has adder calls get adder with a default return value of none if the attribute is not found. Okay, so has adder is a way of using get adder to avoid an attribute error, because it's like a function that says if get adder is not equal to attribute error, then return attribute, else return none. Got it. If get adder does not raise an attribute error, has adder returns true. Get adder does not raise an attribute error. Get adder does not raise an attribute error. Has adder returns true. Otherwise returns false. Gotcha. Okay, understood. Using has adder is, so if we were to implement a simplified version of has adder, custom has adder takes object name, try to do get adder, return true, accept attribute error. Yeah, exactly what I say. Cool. Gotcha. Understood. Everything is a function, right? Efficiency. Using has adder is generally efficient for checking attributes. However, keep in mind that using it can sometimes be slower than directly trying to access the attribute and handling the exception if it doesn't exist, especially in tight loops. Wait, what? How? Using it can sometimes be slower than directly trying to access the attribute and handling the exception if it doesn't exist? How? If that's what it, how is that the case if that's literally what it does? Directly try and access it. I don't understand that. Because the overhead of calling a function is like nothing. Anyway, descriptor, if the attribute is a property or defined via the descriptor, if the attribute is a property or defined via the descriptor protocol, hasAdder will call the getter method. Okay. So if we call hasAdder on a property, it calls that property's getter method. This means that if the getter has side effects or performance implication, using hasAdder could trigger them. Oh, I see what it's saying. We would just try to say, like, if we would just like say try c.x except attribute error return false or something. I see. I see why it's saying that. Gotcha, gotcha. But that would require using like eval or something too. That would require the addition of other logic, which would end up making it just as slow as using hasadder. If the attribute is a property or defined via the descriptor protocol, hasadder will call the getter method. This means if the getter has side effects or performance implications, using hasadder can trigger them. Alright, so the attribute has a descriptor. It calls the getter, but the getter has side effects. So it actually, I mean, if we accessed it, it would still call the getter. Yeah, got it. Okay. Understood? So hasadder invokes getadder, which invokes dunderdict. Gotcha. And then underscore dunder class. We'll just copy that in, erase it, and then paste it directly in. Class. Python, there isn't a built-in attribute or keyword called class. Or maybe referring to several related comments such as the class attribute, which is used to get the class of an instance. Every instance of a class has an attribute called class that refers to the class from which the instance was created. Gotcha. Print instance class, output class, underscore main, my class. You can also check the type, and it's a isn't it a type, like, isn't it type is the type? No, isn't the type of class? I know that's really confusing. Person type. And last, isn't the type of a class type? Yes, you're correct. In Python, the type of a class itself is indeed type. This is an important aspect of Python's object-oriented model. Python classes are first class objects. This means you can create classes dynamically, assign them to variables, and pass them around just like any other object. The type of a class is type. When you define a class, Python uses the type metaclass to create that class, because the class is a type of object. Check the type of the class. Yeah. Yeah, if it doesn't have any parents, its parent is considered a type. Yeah, so if you run my class, it outputs class type. Now, what is the type of type? Well, you can't do that. It doesn't work like that. Alright, mutable versus immutable race condition. Yeah, we already know. Just because the object is immutable doesn't mean it's race. So they're going to take time. Yeah, we already established that. Okay. That was a big excursion, and maybe some of it was overkill, but I felt like I needed to understand that on a deeper level. So we now understand this on a deeper level, so we can actually get back to the code at hand. That was a lot. So now I understand this though on a very deep level. When we run hasadder since the property object, when we run hasadder on the class object, we're just checking to see if it exists. We're not checking the value. So that's of no consequence regarding race condition. We don't actually need the value of the attribute. Then, and I'll just put verified don't need lock for either of these clauses. Has adder doesn't require it, since it doesn't doesn't need the actual return value. True. So, but here for set adder of the object adder name string, we do need it because this is the actual object. Yeah, we definitely need it here. So in this case, we would put if, well, remember we talked about, we know specifically that they're the only, let's see, the only ones that aren't, what was it? Race condition risk. So we'll put, about this, we'll go 1, 2, 3, 4 right here, and then we'll do this. Then I can just do Alt and multiply these cursors, and then we'll go get rid of this one. We'll go to right here, and then we'll say race condition prone. We're gonna copy this, put it there. Now do the same thing. Okay. So we're gonna put a little note here that lets us know which one of these are race condition prone, and we have all this inside of things to do. So choose multiple cards. Let's even this out so we can put them side by side. Okay, so choose multiple cards is race condition prone. Click card active, yes. Enter continue text active, yes. Game state, yes. Input text final, yes. Multiple choice active, yes. Multiple choice text 1, yes. Multiple choice text 2, yes. Progression text, yes. Round and winner sound bool, not race condition. And then selected choice, race condition prone, and then text input active. Yeah, text input active. Race condition prone. Okay. Alright, yeah, cool. So the only one that's not race condition prone here is round and winner sound bool. So all of them. So what we can do is right here, we're just gonna say, we'll just check for if name has round in it. We'll say if round, because none of these have round in it. We'll just do it even more thorough. We'll say if adder name string is equal to round and winner sound bool, rather if it's not equal to. If adder name string is not equal to round n winner sound bool, but hold up, would we even, if it was round n winner sound bool, would we even enter to this if? If it was round n winner sound bool, that's a boolean that, is it a calculated property? Yeah, it is a calculated property, so it would enter into this clause because it would be considered, the class would have the adder since it was a property, and the is instance of that object would be a property object, so that yeah, we would definitely enter into it in this case. So we do need to check for it. So we'll just put this if clause here, which checks for the adder name string being equal to round n winner sound bool, and we can highlight it to make sure it's spelled correctly, which it is. And in that case, we will, so only if it's not equal to it, then we need to use a lock. Use lock, and then else, meaning that if the adder name string is equal to round n winner sound bool, then we can just set the adder, don't need a lock in this case since it doesn't need one, since this adder doesn't require it. There goes my timer. Alright, let's see what we doing here. Alright, so what we need to do here is just implement the lock. So we'll do with, and then we'll access the lock object through this dictionary. We're going to say lock dict at adder name string with lock dict at adder name string. That will access the lock dictionary at that attribute's name. We'll then use it to set that attribute. Grabs the associated lock object. Verified all adders as of 10/3/24 anyway, handled by this clause except the round n winner sound bool adder would need a lock. Would need to use a lock. So yeah, we're going to use the with context manager to grab from the lock dictionary the adder name string. So we still need to create lock dict at appropriate location. All right, and then okay, so then we'll do the same exact thing we did. I'm gonna take a little break. I gotta use the bathroom again, and time 12:36 break. All right, I'll be back in just a few minutes. Alright, we're back. How long was that? 12:36 to 12:44 is 8 minutes. Okay. That wasn't too bad. Alright, so let's go ahead and finish implementing this. So we need to do the same thing here. If add name string is unlocked, okay. So let's put. So actually, in this case, for else, we don't need to check for round and winter sound bool, right? Because round and winter sound bool is a property. Yeah, round and winter sound bool is a property, and we can just verify that by quick Control Shift F. And yep, there it is. Okay, so it is a property. Now we'll close this, go back to client, and undo and redo to get back to our spot. Now we can go ahead and say we don't have to check for round and winter sound bool here. And since that's the only one that's not race condition prone, then we would indeed use the lock. So we'll say with lock dict, and we can just copy this straight up. Lock dict, add our name string, grab the associated object. Alright, so then we just indent that. So in this case, alright, so let's review. And let's just put this right up here so it gets out of the way. Alright, so if applied data is equal to true, then we have if has adder is instance object adder name string, so it checks to see if it's a property at the if it's a class level object, and then it checks to see if it's an actual property, so either a class attribute or a class property, which also an instance property. Here's something I want to see real quick. I thought for sure you couldn't do this. I want to check this though. Can you just make an instance level property? So if we go down to this next one right here, and we say now let's run this and see what happens. Yeah, you can't do that. I thought you couldn't. I don't really understand why you can't do that. Like why you have to define the I don't understand. I want to just ask ChatGPT this real quick. Why does this not work? Why does the above code not work? Why do you have to assign properties at the class level instead of the instance level? The code you provided does not work as intended because the property X is defined inside the init method. In Python, properties need to be defined at the class level. Scope of definition: when you define a property inside a method, it becomes a local variable within that method. It won't be accessible as an attribute of the class or the instance after the method completes. How though? Because everything that you assign within every like attribute, but you can access attributes after the fact. Why would you not be able to access a method? I don't understand. So, but if you just did a regular method, if you just did def m, and then we just pass, you could do print, you could do c.m. Really? Can't do that? Oh, I know why. It's because we're trying to access it as an attribute. Maybe I don't really understand why that is. I don't get it. I don't see. It becomes a local variable within that method. It won't be accessible as an attribute of the class or the instance after the method completes. The property needs to be part of the class's attribute dictionary so it can be accessed correctly. Class's attribute dictionary so it can be accessed correctly. Properties in Python uses a descriptor protocol which requires the methods to be part of the class definition. Properties in Python use the descriptor protocol which requires the methods to be part of the class definition. When you define a property at the class level, it becomes a descriptor that can be accessed through instances of the class. Okay. When you try to access cx on an instance C, Python looks for x in the class's namespace, since x is not defined at the class level. In the class's namespace. Okay. I just don't understand why. Like, I understand how it works, but why, I don't get it. Anyway, it's not important, whatever. I wanted to make sure that I didn't just imagine that that was the case, you know, and that actually was the case. Because sometimes, you know, you make mistakes early on and then you stick with that in your brain and you think it's true, and then you find out later, like, wait a second, that's actually not true. Well, I was right in that case. You can't do that. Okay, so this is all good so far. Let's triple check. So we have the has-adder, the is instance. We check to see if it's a property, and in this case, round end winner sound bool is going to meet both of these requirements. So it's going to enter into this section, which checks to make sure it's not round end winner sound bool. As long as the adder name string is not equal to round end winner sound bool, we can then use with lock dict at the adder name string using the key as the adder name string. We will access the associated lock object, where we grab the associated lock object. We verified all adders as of 10.3.24 anyway, handled by this clause, except the round end winner sound bool would need to use a lock. Okay, true. Then we have set adder that just sets the attribute. And then we have else, so if the add name string is equal to rounded winter sound bool, we don't need to use a lock in this case. We just set it directly. And then else, meaning if it's not a class property, then if it's just a regular instance attribute, then that does include the input text final, selected choice, and text input active, which means that all three of those need a lock. So we then would always use the lock with lockdict add name string, which grabs the associated lock object through that dictionary, and then we set the attribute using it, and it will automatically release because we're using with the context manager, which automatically releases the lock when the execution of that line is done. Okay, now we have to create this lock dictionary, and we also need to create the locks. So let me put this where it actually should go, which is in things to do. We'll go up here. So what is that? Go back to check when we do. This was adding that to check for sure. Check receive. Progression tag, skeleton clickable, skeleton click guard. Alright, create lock dict at appropriate location. Still need to create locks. So create lock dict, game lock dict. So this is the game lock dict. Create game locks. Oh, we need to create all the locks. Actually, I haven't created any of them, but they all are for game. So we put game locks. Alright. And I might need to go back and review some of these that I thought weren't shared. I think they might actually be. We'll triple check. So, what are we going to do first? First, we'll create the lock, and we determine that we can create the locks wherever the associated attributes are, because we shouldn't have import issues, because the lock only goes where the attribute goes. Yeah, okay. So let's go one by one and create the locks. Let's close that out. Alright, so we have to expand this, and then let's do choose multiple cards first. So we need to create choose multiple cards lock. So we'll do Control C, go over here, do Control F, and then we'll do self dot choose multiple cards. Now, okay, so right under this we'll create the so we pass the lock in. I just want to make sure we can do this the way that I'm proposing. So we have the, let's see, where is it? We have the cal lock list function. Well, we also have the data transfer function. Okay, so we don't actually use a lock argument for that, and that will be a problem because if we created the locks alongside the associated attributes, that means in game we would have these locks created in the scope of in this case, the game file. And in game, we import change attribute list to have access to the data transfer function. Okay? So whenever we import the change attribute list data transfer function, we would have to pass that lock from the game file to this location through argument passing, which means we would have to create a new lock parameter for the for this function. Well, actually, wait a second. Would we actually need to do that? Yeah, we actually would need to do that. We actually need the lock, so let's do choose multiple cards. We actually would need the lock. Let's just find where this is defined at. Alright, here we go. So we have choose multiple cards here. I think this terminal is much smaller. We don't need that right now. Alright. Choose multiple cards setter. Okay. Change from your check is equal to true. Dust mite allergy, I have to make sure I treat my stuff. Anything that's like fabric, the dust mites could get in and they cause me to like itch. So I have to like periodically treat my stuff. Anyway, so we have the setter here. So as we said, we don't need the lock to access the actual object itself. I really only want to put the lock exactly where we need it and then remove it, you know, exactly after we need it and when we no longer need it. I don't want there to be like a bunch of dead space between. So well, actually though, we would want the setter basically anytime we accessed the setter, we would want the lock to be acquired because we don't want the getter to be accessed while the setter is running. If the setter starts first, then the setter started first, and it should finish first. So we would, in this case, I think, immediately use the lock for the entire setter method. So we would say with, and we'll just call this the choose multiple cards lock. With choose multiple cards lock, we want to lock all this shit. Yeah. So with choose multiple cards lock, we do all this. And yeah, then also in the getter, we would use the same. We would do the same thing. So as soon as we went to retrieve it, we would use the lock. Now, would we need the lock inside? Well, then we would have to have a reentrant lock because we call data transfer function. But we don't actually need it there because we don't pass. We don't handle the actual object. We just pass in the data itself. We extract the data from the object, the attribute object, and then pass that data in separately. So yeah, we don't need it for this. We don't need it in this location, that is. Yep, we just use the data itself. We don't actually pass in the attribute. Yeah, so we're good. We don't need it there. Alright, so we can exit this out. So that means we can create it. We can create the lock alongside the actual attribute in its original location because we don't need to pass it anywhere else. So we can go to I didn't create it yet. So let's copy it, and we're actually going to call this is going to be the self. Yeah, because there needs to be one for each game object, right? Yeah, because P1 games lock is going to be separate from P2 games lock, obviously. So with self.choose multiple cards lock, and then we'll go all the way to the top here, find choose multiple cards equals alright, yeah, so right here we need to create it. We'll say use our little template here. And then created 10, 3, 24. And I don't want to forget I gotta pay my mortgage. Just waiting for some money to come through before I pay the mortgage. Because I have lots of stuff going out of my account, so I want to make sure, you know, all the money's there before I make payments on my stuff. Alright. So this is going to be the type, it's going to be a lock, and purpose is going to be to lock the self.choose multiple cards, adder, we'll just say setter, and getter to ensure no race condition issues. Since the adder is verified race condition prone. And so we're going to say threading.lock. So threading. Not import threading here. Okay, yeah, we need to import threading. And what line are we at? This is line 301. So that's 301. Alright, so now we have created our choose multiple cards lock, and it was created 10.3.24. It's the type. It's a lock object. The purpose is to lock the self, choose multiple cards, setter and getter to ensure no race condition issues. Since the adder is verified race condition prone. Good deal. Okay. And we're gonna copy that comment because we'll probably use it again. Alright, so let's to next one, and let's go over here. Actually, we can minimize this. Create game locks that we're doing right now, and let's recopy this list. Copy that, minimize it, paste it in. We can just have Man, that storm, huh, Helena? Holy shit, dude. Man, unbelievable, dude. Like, in fucking North Carolina, Tennessee, like, what is going on here? You know, this is not, I don't know if that's ever happened. I don't really keep up with it too much, because I'm in Louisiana, but I don't think that's ever happened. Maybe I'm wrong. That's just not something you really expect over there. You might expect to get a little bit of the ass end of some of the storms, you know, which usually aren't, even if it's like a strong storm when it makes landfall on the coast, by the time it gets to those states, you know, non-coastal states, you just don't expect that, bro. And wow, terrible. Yeah, you know, that could have been us, bro, with whatchamacallit, storm, that one that just passed. I forgot the name of it already. Alright, so we created choose multiple cards. Now we're going to do click card active. So where are we at here? Clients. Used to do click card active. Alright, so let's just go back over here. Let's do click card act. Whoops. I don't know how that happened. So let's see, is this a property? It is, okay, so it's going to be easy to implement a fix for it. We're going to go to where it's defined right here, and then we're going to do self dot. Well, yeah, I mean, I was just thinking, worried about importing, but yeah, like we said, this lock is only going to go where the attribute goes, so there shouldn't be any issue with imports. So we can do self click card active lock equals threading dot lock, and it doesn't need to be a reentrant lock, I don't believe. And then we can go to right here, this lock comment, and we can copy the whole thing right there. There we go. So we have click card active lock equals threading dot lock, created 10.3.24, type lock, purpose locks. So, oh yeah, I have to change that too. Good thing I read my, you know, double check my stuff, because if I didn't, I would be totally screwed. To lock the self click card active setter and getter to ensure no race condition issues, since the editor is verified race condition prone. Alright, so now we're gonna copy this, and then we're gonna go to the setter and the getter, and we're gonna put with self dot click card active lock return self click card active. Yeah, so basically whichever one started first goes first. It's really simple. So with self dot click card active lock, and this would apply. Oh yeah, well, we only need to do this if it's client side, right? But didn't we say checking for client side would be, well, no, acquiring and releasing a lock is 3 times slower than using an if elif. So we actually only need to do this on the whatchamacallit, on the server side. We don't need to do this client side. So we need to actually put if changed attribute list.ss or cs is equal to ss, we would then use the lock. But else, meaning elif change attribute list ss or cs is equal to cs, meaning it's client side. In this case, we don't need to use a lock. And since the checking to the SS or CS is faster than acquiring and releasing the lock, we would opt to check for SS or CS prior to determine if we should use the lock. Because yeah, only when SS or CS is equal to SS for server side would we use the lock. Otherwise, we would not use the lock. So we need to add this here. Let's say if change attributes. See this? We're gonna put this in a function. So I fucked up my indentation. I don't know why it does that. So we're gonna put this code in the function. Let's undo all this. Copy all this. I don't like this. Something's not right with that. It's not terrible, but I think I'm gonna go take a break. I'm gonna go eat, and I'll come back later, and yeah, come back later. So we're at 2 hours and 11 minutes. Yeah, I'm gonna take a little break and eat and get some more caffeine in my system. Feeling a little sleepy, maybe a little hungry. It's almost 1:30, so I'm gonna go eat. All right. I'm gonna figure out something to do with this, cause I don't really like the idea of doing this function within a function thing. And where should I define the function? Should I use a function? Should I just paste the code twice? I don't really like pasting those, you know, another like 10 lines. It's just makes it ugly, hard to read. I don't like it. So we'll put break 123 XX, and then we'll come back. So we'll put break 123 line 525 game. So here. Alright, yeah, so I'm gonna take a little break and I'll be back, guys. I'll see you in like an hour or two. About an hour-ish. And yeah, we'll get some done.